Before we get started with the presentation, shout out to Milan. He'll be monitoring the chat. So if you have any questions throughout the presentation today, feel free to drop those questions into the chat. Yeah, so with that, let's get started. Yeah, so first, I just want to start off with just a couple things about who we are, what big data is. So yeah, Big Data at Berkeley is a student organization. We're interested in data science, so we have two main committees. The projects committee works with startups, and they help companies make informed decisions and improve their products and consumer relations. And then we have the education committee, and that's where me and Milan are from. So our main mission is to spread data science knowledge and try to give back to the community as much as possible. So yeah, that's a little bit about us. So now let's get into, what is data science? So two main points here. First part, the biggest important thing about data science is, well, the data. You'll be working with data, cleaning, processing, and analyzing the data. And you're really doing this to gain some insights into the data, look for trends, and potentially, build models based on the data. And data science is a very interdisciplinary field. It draws on knowledge from a lot of different areas. So, it involves programming knowledge, and today we'll be using Python. So you'll get to see some Python code. It involves some statistics knowledge, and then it also involves some domain knowledge. So, what is domain knowledge? It's really any field-specific knowledge that could be useful when you're analyzing a data set. So for example, today we'll be looking at a COVID-19 data set. So, some domain knowledge that could be useful for that could potentially be maybe like epidemiology or biology, something like that. But yeah, domain knowledge is dependent on your data set. And here's just another visual just to see what that looks like. We can see programming, math, and algorithms, and then domain knowledge, or data science is at the intersection of those three. Yeah. All right. And then we're going to talk a little bit about the ethics of data. This is a pretty relevant topic in data science, especially, today we heard about a lot of tech companies like, Facebook breaching data privacy of their users. So I think it's an important thing to talk about, and it's really relevant to a lot of tech companies today. So here's some main key points about ethical data collection. First one, it's important to get proper consent from your users. You don't want to be collecting data without user consent. Don't always rely on third-party data, which this basically just means companies should try and collect their own data rather than relying on data that you may not know where it comes from. You may not know how reliable that third-party data is. Limit your data sharing ability. So you don't want different applications to be able to just share data too easily. This is where Facebook actually their main point where they messed up. Their applications were communicating and sharing user data where it shouldn't have been. And then the last point is to just try and be transparent on the uses of the data. So make sure your user knows how exactly their information is being used and what it's being used for. So yeah, those are just some main key points about ethical data collection. All right, so now on to the main topic for today, visualizations. So yeah, why do we care about visualizations? So the main point is that they make it easier for us to analyze data. If we can turn our data set into something that's readable, like a chart or a graph, it's very user-friendly. It's much easier to interpret than just a giant table of numbers. Yeah, so today we'll be covering 4 main types of visualizations. We'll talk about scatter plots, line graphs, bar charts, and histograms. So let's get started first with some terminology. I'll be using this terminology throughout today, and these are some basic terms that are useful in data science too. So the first one is numerical data. So this is a data with numerical values, which is really anything that can be measured. So I have an example here, the number of movies an actor has been in. So yeah, anything that can be measured would be numerical data. Then the next one we have here is categorical data. So this data represents characteristics, and the example we have is movie studios. Yeah, so it's categories. So another example could be like colors, animals, anything that could be a category. Now, I just want to point out an important distinction. Just because data has numbers in it does not automatically make it numerical data. That's an important point. So one good example could be a zip code, right? So different zip codes, like zip codes technically have numbers, but they don't actually measure anything. They would actually be an example of categorical data. And actually, I think we'll be touching up on that again in a bit. But yeah. Yeah, so then the last term we have here is distribution. So for any given value of variable, it's how the frequency of how much that variable shows up. More intuitively, it really is just how often a value, or it's like a representation of your value and the spread of it. And we'll see some examples of a distribution in a bit. Yeah, so on to our first example of a visualization. We'll be talking about scatter plots. So scatter plots are very useful for finding the relationship between numerical data. So if you look at the example right here, we have an x-axis, which is measuring the number of movies, and the y-axis is measuring the total gross amount of money they made. So both of these are numerical data. And one thing that you can use scatter plots for is to find a relationship between these two variables. So if we look at this, we can see most of the relationship is clustered around here, but there is a slight positive relationship. So, one of the things you can look at between this, you could interpret from this is, there is a relationship. A higher number of movies means there is a bit higher dollar value for that. So one thing you can use scatter plots for is looking at if there's correlation between these two variables. So we could potentially say that there is loose correlation between these two variables. But yeah, now I'm going to go into an example real quick before I do that. For those of you that joined a little late, I'm going to send those links in again. So the first link again is a link to the folder with the slides and everything. I think I may have forgot to mention what the second link is for. So yeah, fill out the second link as well. The second link is a form that you can fill out, and it's just going to be like some questions about you. What's your favorite color, things like that. And then I'm going to show you guys like some cool visualizations based on that. Depending on how many people fill it out, if the more of you fill it out, the cooler it will look. So just go ahead and try and fill that out. But yeah, so the first folder is where you can find, or the first link is where you can find the code I'll be working on. So yeah, let's go ahead and switch over to that. I think I'm gonna have to reshare. So. All right. Oh wait, sorry, wrong screen. I think this should work. Give me 1 second while I figure this out. Okay, there we go. um, so yeah, this tool I'm using here today is called Google Colab. And what it lets us do is it kind of just, we can run code in this notebook and we can see the output of that code at the same, after running it. So it's really useful for data science. It's used pretty commonly. And you can open it straight from your Google Drive. So if you guys want to follow along, go ahead and open up that first link. And you can access this notebook. And yeah, so I'll get started so that you can go ahead and just run this first cell. You don't need to change any of the code there. I'll explain a little bit of what this is though. So what we're doing here is we're just importing different libraries that would be useful. These are all Python libraries that we'll be using today. First one is NumPy. That's an important one that you'll commonly use in data science and just has some built-in functions that are really useful for us. And then we have this thing called the data science module. This is something we're using it has some built-in data science functions and methods that'll be useful for creating visualizations. Another one we're using is matplotlib. This is something that's gonna make our visualizations show up and look nice and readable. So yeah, those are just some things we're using. The data science module is something that's really useful for people that are beginners in data science. So it's perfect for people, if you don't have too much experience, it's perfect starting off point. So yeah, let's get started with that. Go ahead and run this cell. This is what's gonna let you access the file in your Google Drive. Mine, I've already run it before, so that's why it says drive already mounted. But when you run it, it'll take you to a link with an access code. Go ahead and enter that code into this pop-up that'll show up, and you should be good to go. And if you have trouble with any of this, for those of you that are following along, go ahead and drop questions in the chat. But yeah, then we're gonna run this cell. In your version of the notebook, I left a blank after my drive. So this is the path of where my COVID-19 dataset CSV file is located. So these are all of the folders where my file is inside of. So you would replace these with wherever your file is located. Yeah, so you can fill that in based on how it is for you. So after I run my cell, we can see the COVID data set. So it has lots of different columns. It has the observation date, a province, a country. It has the number of confirmed cases in each of these locations, the number of deaths, the number of recovered people. So it's some pretty useful information. So what we're gonna do first, we were talking about scatter plots. So first I'm gonna create a scatter plot. We're going to look at the relationship between confirmed cases and the number of recovered people. So this will be useful to see, as cases increase, are people recovering at a similar rate or not? We can see if there's a relationship there.
Sorry,
So
Daniel. Looks like your screen's like kind of popping on and off. Do you mind just stop sharing and sharing again?
yeah.
Thank you.
Was it like, what was going on with
It's
it?
like we can only see like a part of the screen. We weren't able to see everything. All right, looks
Okay.
good now, but if it happens again, I'll let you know.
Okay, cool, thanks.
Mhm.
Yeah, so we're gonna go ahead and create a scatter plot comparing the relationship between confirmed cases and the number of recovered people. Um, so if you look up here, when we read in the table, we assigned it to a variable called COVID. So I'm gonna use this variable to reference this table. So that's how we'll access all of that data. So the first thing I'm gonna do is get the COVID table. And then we're gonna use a function .scatter, which is what's gonna actually let us turn this into a scatter plot. Now .scatter, it'll take in two arguments. The first argument is going to be the column that we're using for the x-axis, and then the second argument will be the column for the y-axis. So if you want to compare confirmed cases to the number of recovered, if you look at our table right here, we can see that there is a column called confirmed. So we'll go ahead and use that column. And when you reference the name of the column, you have to pass it in as a string. So what this means, it'll be in quotes. And if once it's in quotes, that means it's a string, which means you're really just referencing the name of the column. So yeah, there's confirmed, and then we want to compare it to the number of recovered. So we'll use this column right here, recovered. It's a similar idea. Let's use recovered like that. And yeah, we'll go ahead and run this cell. Yeah, so we see this interesting scatter plot. It looks a little different from what you may be used to seeing for scatter plots. And my interpretation of it was, all of these are the trend lines for individual countries. So they're all pretty different because COVID has unfolded really differently in different countries. So, we can see, like, for example, like this country that's going way up here, they really got their recovery rate skyrocketing at 60 something thousand cases. They really got things going in their country. So yeah, that's so that's the trend line there. So now we'll move on to the next type of visualization for today, and that's line graphs. So line graphs are really useful for showing numerical data in sequential order. And usually, the x-axis is time. So we can see, how is a certain type of data changing over time. If you look at the example over here, we're looking at the number of movies made over time. And we can see that, over time, the number of movies is increasing by a bit, So it's really useful for looking at data over time sequentially. And we're going to go through another example right here. So what we're going to look at is, oh, by the way, for those of you that don't know, I live in California, so I was kind of interested in looking at the trend of confirmed cases in California over time. So that's what we're going to take a look at. For those of you that are in different locations, you could definitely modify the code to work for wherever you're at, if you're interested in looking at that. So yeah, we're going to do a similar thing where we're going to get that COVID table. But now we want to filter it down, right? Because if we look at this COVID table, we have lots of different countries and lots of different provinces. But we're only interested in looking at California. So the first thing we need to do right off the bat is filter this table down. And a really useful function for that is .where. Right, so this is going to look at where something, or yeah, I'll just walk through the example. So we're going to look at where, so we'll take in two arguments. The first argument will be the column that we're looking at. So in this case, we are looking at where the province or state is going to be California. We're not interested in all these other provinces for the time being. We're only interested in California. All right, someone said that they cannot see the screen. Let me share it again. That's very weird.
I think that was before.
Oh, okay.
Yeah, we're good now.
Okay, cool. Okay, yeah, so we're interested in seeing where the province or state is California. So for the first argument, we're going to specify the column. So we're looking at the province/state column. And then the second argument is going to be the value that we are looking for within that column. So within the provinces and states, we are interested in looking at California. So I'm going to go here and pass in California. So yeah, that's useful because now we have it filtered down, And actually, we can take a look at what this looks like for the time being. Yeah, so we can see that the table is all of the times they measured California. So now we're going to go ahead and turn this into a line graph. So to do that, we use the dot plot function. And there's a couple ways of actually going about this. We could use the observation date, but these are categorical values, and we would need to convert them. We would need to find a way to measure them in sequential order. But I noticed that there's actually this other column, S and O, which is actually when they took these measurements. And we can see that, as these numbers get bigger, it's later in time, right? So these are the earlier measurements, 205, and this 5,329 is a later measurement. So this is actually a pretty convenient measurement of time in our case. So I'm going to actually go ahead and use that column. And yeah, so this will be our x-axis, and then we need our y-axis, and we're looking at the number of confirmed cases over time, so we're going to use this confirmed column right here. Yeah, let's take a look at that. Yeah, so we can pretty clearly see that California's confirmed cases have gone quite a ways up over time. Yeah, cool. Well, let's move on to our next type of visualization, which is bar charts. So yeah, bar charts are really for looking at distributions of categories. The axes are going to be categorical values, and if we look here, the y-axis, they're all categorical values. They're different studios like Warner Brothers, Fox. And the other axis is going to be numerical, so it's just counting the number of movies that each studio has made. So we can see that Warner Brothers and Disney have made the most. So yeah, it's really useful for looking at categorical values and being able to compare different categorical values. Yeah. So now I'm going to go through an example of bar charts comparing confirmed cases, and I decided to look at countries with confirmed cases of 3,000 or more, just because there's lots of countries with less than 3,000 cases, and they don't really show up, like they show up with a very small amount. So we're really just interested in looking at countries with lots of cases. So there's going to be a couple steps for this. First, right off the bat, we need to be able to sum all of the cases for a country. So if you look at this, we can see that they take multiple observations on the same day in different provinces. So what we need to do is combine all of these observations into one value so that we can compare all of the values for a given country with with all the values of other countries. So yeah, let's go ahead and do that. So I'm going to go ahead and create a new variable called countries summed. So what we're going to do in this line of code is we're going to just do exactly what I said. We're going to sum up all of those values. So first things first, we're going to, like always, get that COVID table. And once again, I'm going to use the .where function. And this time, I'm interested in looking at, I'm interested in actually looking at an observation date. So what we're going to do is actually look at the latest date that this data set has. So I looked at it, I checked it out, and the latest date that it has is March 3rd. So we're going to go ahead and do that. So it'll be observation date. And we're going to look at when that's equal to March 3rd. So that'll be 04/03, 2020. This is the latest date the dataset has, so it is a bit outdated now. I'm sure you'd be able to find some more up-to-date ones if online, if you're interested in that. So yeah, we really just want to look at the latest date to see what the most current trends are. And then we're going to use the dot group function. So this is a function that's going to let us group all these different provinces together, or actually all the different countries' values together. So we're going to group all of the mainland China values together. And we'll do the same thing for the United States and all the countries in this table. So to do that, first things first, we're gonna get the country. So it's country/region. And then the second argument is going to be the function that we're using. So we're looking at taking the sum of all of these. We want to combine all the cases for a given country. So this will do that. Sum will allow us to just add it all up. Yeah, so that's the first part. Then we're gonna go ahead and actually let's just take a look at this and see what it looks like. Oh, sorry. Yeah, so if you ever want to look at what something looks like, you just put it at the last line of code and you'll be able to see. So yeah, we can see that we combined all these confirmed cases for each country and as well as deaths and recovered cases. So we can see that we have the added values for all of those. Now what we're interested really is just the confirmed cases though. So I'm gonna actually just select. So this dot select will let us pick exactly which columns we need. So I still want to know which countries that we're looking at, and I want to look at the number at the confirmed cases. So the column is called confirmed sum. So now we only have those two columns. All right, cool. And the last part of this, the last part of the filtering process is, we're interested in looking at countries with 3,000 or more cases. So to do that, we're once again going to use the dot where function. So it'll be where confirmed sum. And this is going to be, we're going to use something called r.above. So this will let us look at anything above the value that we specify. And in this case, we're going to specify 3,000. So now we're looking at everything above 3,000. So we have all these countries right there. Yeah, so last part of this now is we're going to turn it into a bar chart. But actually one more thing before we do that though. So we have all these countries, but it's kind of out of order. And it might be kind of hard to read if, we have smaller values mixed in with larger values. Like if we look at this one right here, it's ordered really nicely. We can see that it starts with the largest ones all the way down to the smallest ones. And that makes it really readable for whoever's looking at this. So we're going to actually do that just so it's easy to read. So I'm going to sort our table right here. And with the dot sort function, it's similar to some of the other ones we've used where you want to specify the column that we're looking at. So I want to look at the number of confirmed cases we have, and I'm going to order that. So the second argument is where I specify how the ordering is going to be. So we use descending equals true. Now what this means is that it's just going to start from the largest value in our table and just descend from there. So yeah, so that'll sort it. And last part of this is to just turn it into a bar. So to do that, we use the bar h function. and you just specify the column we want to look at, so it'll be country/region. All right, cool. So we have this visualization of confirmed cases in all these countries. We can see that the United States is at the top and Philippines is at the very bottom, but yeah, pretty interesting visualization. Okay, I'm gonna go out of full screen because, so are you guys having trouble seeing what I'm presenting?
Yeah, at times what it looks like is we can only see like a strip of your screen, but it's going on and off, so we can see it eventually, but it's just like continuously switching between the two.
That is very weird.
Yeah, maybe if you try not full screen, it might work. So
Yeah, that's what I'm doing now. Okay, can you guys see everything now?
yeah, looks pretty good on my end. Can somebody else also type in chat just so we can get confirmation? Okay, it looks like people are saying looks good, so we're good.
Okay, cool. Is there anything that cut out before you guys want me to go over, or are you guys good? Just type in the chat if there's anything. All right, looks like you guys are good. So I'm gonna go ahead and move on to the next visualization that we'll be talking about, which is histograms. These ones are a little complicated, or a little more complicated than the other ones we've talked about. So yeah, so histograms are really useful for looking at distributions of numerical data. And they use this thing called bins, which is really just a range of values. So there's one bar that's going to be corresponding to each bin that we have in our table. So if you look at here, our first bin is looking at from the first 400 values, and the second one is from 400 to 600. So we can see that, and I'll go more into bins in a second. But one thing I just want to point out first is, so each bar represents, or the area of each bar represents the percent out of the total share of data that we have. So for example, if this, just to calculate the area, you would look at the length times height of each bar. So the first bar has a length, or the width of 400. The height would be 0.38 or something like that. And so if we turn that into decimal of like 0.038, so if we multiply 400 by that, it'll be somewhere around 15. Oops, so sorry. So it'll really just be 152.
It'd be 15.2%.
15.2%. Yeah, so that bar will represent 15.2% of the total data. So yeah, here's some more stuff about bins. So one thing that's really important is to understand that bins are defined by their lower bounds. So the lower bound is inclusive, the upper bound is exclusive. So what that means is that this, for example, this first bin right here is going to include all the values from 160, because the lower bound is inclusive, to 164, because the upper bound is exclusive. So this next one will be 165 to 169, and then 170 to 174, and so on. So yeah, that's one really important thing to point out about histograms or bins. And then, yeah, we're just going to talk about histogram axes a little bit. So one thing is that, since each bar represents the percent of data out of the total amount, if you add up all those values, then that should equal 100%. If you add up the areas of all the bars, it should be 100%. So in other words, the area of each bar is a percentage of the whole. So yeah, the horizontal axis of the histogram is going to be numerical values. And the bars, they don't have to be equal in size. So let's look at um, these. Like, so the first one, it's from 0 to 400, but then it only increases by 200 in the next bar. So we can see that these are different sizes. And, there might be some cases where that's useful to do, if you have like outliers in your data, things like that. Yeah. And then the vertical axis is a rate. So something like percent per year. In this one, you had percent per $1,000,000. So it's some sort of rate like that. Yeah, and last thing about histograms, I just want to kind of talk about the difference between histograms and bar charts. So they look kind of similar, but they are measuring different things. Bar charts are looking at a distribution of categorical variables, whereas histograms are looking at distributions of numerical variables. Bars have arbitrary but equal widths and spacings. So you'll see that each bar they look like they'll be equal in size, and they might have gaps in the data. So like where like a given bar, if there's no values in that bar, then it'll just be blank. Whereas with histograms, you can't have any gaps because the bins have to cover, bins like have to all cover like a certain amount of data, and they'll all kind of lead into the next one. Yeah, I'm just gonna actually go ahead and go into the example now because we're running a little behind. Yeah, so over here we're gonna create a histogram that's gonna measure show the frequency of confirmed cases. So we're gonna kind of be able to see, how common is X amount of confirmed cases. Yeah, so to do that, I'm actually gonna use a variable that we defined up here, country summed. Because with country summed, we have all of the summed number of confirmed cases for all of the countries. So that'll be useful. You can see how common a certain number of confirmed cases is amongst all of the countries in that table. So yeah, we're going to use the .hist function. This is what lets us turn this table into a histogram. And then we're interested in looking at the confirmed sum column. So that's the first argument, the column that we're looking at. The second argument, actually, let's just go ahead and look at what this looks like first, and then I will talk about the second argument. Yeah. So if you look at this, it's not super readable right now. I mean, it is, but it's not like super useful because we can see that our first bin is huge. So most countries have cases that are from 0 to what is that, 25,000, I think, or somewhere around. I don't know exactly what that value is, but somewhere around there. But maybe if we adjust the bins, we'll be able to get a better picture of our data. So the second argument, it's optional, but you can specify it. It's the bins that we'll be using. And bins, this argument, it takes in an array of values, and that array is going to be used to create those bins. So to do that, I'm actually going to use a function called np.arrange. So np.arrange lets us create an array of values. So the first argument of np.arrange is the starting off point. So we're going to start at the number 0. The second argument is the stopping point. And I'm actually going to stop at 150,000 just because, we have a lot of empty values right here, right now. From 150,000 to 250,000, there's nothing there. And these ones, they're not really, there's just a few countries there. So we can just cut it off at 150,000 like that. And then the third argument is the stepping amount. So this is actually going to determine the size of your bins. So I'm going to do 15,000. I was playing around with this before and I found 15,000 to look nice, but you can mess around with it as well. You can adjust the bins however you like, and you might find something that looks better than what I found. But this looks a little better now. um, we can see similar trend. Most cases are pretty low in most countries, but then, there's a few countries at this end over here that have higher cases. So it shows us, the frequency of the confirmed cases in all these different countries. So yeah, that's histograms. So those are all the visualizations that we're covering today. I do want to just talk about quickly before we go on to the Q&A session. I just want to talk about quickly what we were using today, the technologies that we were using. So we were using the data science module. So all of those functions that you saw me using, like .scatter, .hist, those functions, come from the data science module. So it's useful for beginners. And I have a link in these slides, and it kind of has like some useful like guides on like how to use those functions and stuff. Now this other one, this other library that I have listed here is Pandas. Now Pandas is the industry standard. So most companies will use Pandas. And functionally, it's really similar to the data science module, but the syntax is different. So I have an example of the syntax. So over here, I have table.read table, but in pandas, it's pandas.read CSV. I have a link. So we didn't cover pandas today, but if you're interested in that, you can definitely check out that link right there. And you can totally read up about, what the syntax is for that and all the different functions for pandas as well. So yeah, those are two useful links. So we do have 15 minutes left. So I'm actually gonna go into the Q&A session right now. And if we have time, I had one other thing planned, and if we have time, we'll go ahead and do that. But for now, we're gonna have a Q&A session. So I'm gonna be in one of them, and Milan will be in the other one. So we'll have two going on at the same time. Or actually, that was the original plan, but we don't have a huge number of people. So I think we can actually, me and Milan can go ahead and just do it together. We can both answer questions right here. So yeah, during this time, you can honestly just ask questions about anything, whether that's, data science questions, about like what you saw today, the different functions that we used, or it could just be more general questions, general questions about what it is like to be in the data science major. Me and Milan are both data science majors. You can ask about that, or even just general college questions, really anything that's useful to you. You can ask those questions in the chat, or you can, open up your mic and ask as well. So yeah, just go ahead. Anybody have some questions?
Looks like we have one in chat. What do you find the most interesting about data science?
I think I can go ahead and answer. I think it's really cool because it's applicable to so many different fields. Like right now we looked at COVID data sets, but really I've worked with data sets with like that have to do with music. Milan really likes sports data sets, things like that. So it's applicable to so many different areas that you can definitely find something that you're personally really interested in and apply data science to that. So that's one of the biggest reasons why I'm interested in data science.
Yeah, and I can kind of agree with Daniel's point there. One of the things I like the most about data science, and it's also pretty interesting, is you get to interact with so many different people with so many different backgrounds. It's made really collaborative because you can apply it to so many different places. So being able to like learn from others and being able to apply it to other places, you'll meet a lot of people in the way, and I think that's been one of the most interesting to me.
Yeah, definitely. Yeah, we have one other question. How do you find outliers in a data set? Let's see. Well, one thing you can do is, we talked about distributions today.
Mhm.
One thing you can do is look at, the spread of your data when you create, these visualizations and see, do I have, like we saw earlier with that histogram, we saw a bunch of gaps and then some values at, the highest end. So if we see something like that, we know that those are outliers. Milan, do you have anything to add to that?
Yeah, so what Daniel did today with all the different visualizations, what that's called is exploratory data analysis, or EDA. So if you do that with your data set, you can find information about the data set and potentially find outliers. So basically, it's just a matter of looking through your data set, making visuals and stuff like that. Basically, everything Daniel did today.
Yeah,
Good
definitely.
question right there.
Yeah. And like some things that could be useful for that is also like looking at what the mean, median, and like the standard deviation of your data set is. Um, that can help you find those outliers. All right, any other questions? Can really be about anything, like college, data science, anything you guys are interested in.
If you guys want advice for any personal projects, how to go about finding something to do with data science, those are also valid as well.
All right, okay, cool. So I have one question privately, and then we have another one in the public chat.
Mhm.
So I answer the private question. Um, so it's about how do you start research in high school? Um, in high school, I don't know about any official research organizations in high school, but you can definitely, if you're interested in like data science research, you can definitely look into Kaggle. Like there's data sets there, and independently you can analyze. That's kind of like how I did today. You can pull up those data sets and just like Milan was saying, exploratory data analysis. You can do that on those data sets. And Kaggle also has built-in competitions that you can participate in as well. So that's a great starting off point for high school. It shows initiative as well that you're going out of your way to do those things. Um,
Yeah, and to add on to Daniel's point, I've linked something in chat. It's called Towards Data Science. So that's where you can find a lot of like articles to read about. And once you get ideas from there, you can also see what others did. And seeing what everybody else did with their like articles, with their work, you can also follow the same steps. Because basically everything is doable still, even at a high school level. So you can just follow along there to maybe get a head start and learn more.
yeah, definitely.
I think we have Neural Hacks question. Anyone want to explain your project idea so far? So I think, if I'm not wrong, that's more for the students. Um, but,
Anyone interested?
but yeah, if
Um,
anybody wants to share their project idea, get like maybe mine or Daniel's perspective on it, you can also go ahead and do that.
In the meantime, I do have one private question. How is UC Berkeley for computer science? Um, yeah, so we both are data science majors, but we take lots of computer science classes. And yeah, it's a great school for computer science. The classes do tend to be pretty rigorous and time consuming. Um, but there's also a community, there's lots of support classes. Milan was actually part of one of those support classes that you can take. So that you can take those classes to kind of help out. Um, and kind of like get some reinforcement for the more difficult concepts. So I have one more question, a private question. How do you start a project with neural hacks? Is it independent? So I'm not like officially with neural hacks, so you can ask that question to the neural hacks people. But I mean, most hackathons that I've been to, you just start a project and you submit it. I think that's the case as well. But yeah.
As for resources and starting your own project away from a hackathon, just finding what others did and like using that source code that's already published, you can just start from there and maybe like take it to your own like perspective. So those are also other possibilities for doing your own personal projects.
Definitely. All right, any other questions? All right, so if there's no more questions, I think I can quickly walk through this visualization notebook I had. If you have questions still, feel free to drop them, but I'm gonna go ahead and check that out. So if for those of you that filled out the form, or let's see how many people filled out the form. Okay, yeah, that should be enough. So yeah, we're gonna go ahead and take a look at this. Just give me a minute or two to get it set up.
And also just want to add, same with me. I'm not in the Discord for neural hacks, but if anybody has any questions, you can feel free to connect with me on LinkedIn and you can just message me anything you guys have. So I'll drop that in the chat. I'll drop my link in the chat. Feel free to connect and ask anything you guys have if it comes up in the future.
Yep. Yeah, it's almost ready to go. All right. Okay. So yeah, we asked you all those questions because we kind of just wanted to look at some visualizations based off of what you guys answered. This is always just kind of fun to look at. It's interesting. So first, what we're doing here is we're just reading in all of you guys' data. And this is an example of ethical data collection because we got your consent before we did it. Yeah, so this is just cleaning and organizing all of the data so that it's easier to work with. So what we're looking at here is names, the first letter of first names. So we can see that A, J, and P are the most common first letters. And with last names, we're doing a similar thing. But for last names, S is the most common letter. So yeah, cool. So this one is just looking at which social media is the most popular. So it looks like Instagram is the most popular. Then Facebook and LinkedIn. Wow, I've never seen LinkedIn up there, but that's cool. Nice. Here's a visualization for favorite subjects. So wow, lots of people that like physics, but we have a pretty diverse group of subjects. French, that's cool. I've never seen French up there. Nice. So here is people's favorite color. So we can see that blue is the most common favorite color. Nice. How much sleep people are getting. All right, so it ranges from 6 to 9 hours. More people from 7.5 to 9 hours. That's good. That's a decent amount. Let's look at a scatter plot. So yeah, I mean, we don't have a ton of data, so it's hard to see any sort of trend. It is pretty scattered around everywhere, but yeah, I mean, looks like some of you guys are studying a lot for 7 hours of sleep. um, but yeah, that's nice. Let's look at this one. Oh wait, that one's just. So yeah, this one is looking at height by year. So it looks like we don't have too many people that are sophomores, juniors, and seniors, but within freshmen, there's a pretty big range in height. Yeah, but on average, freshmen are shorter than sophomores, juniors, and seniors. Cool. So the last visualization we have today is, if you're tall, do you have a bigger shoe size? So it seems like, well, for one, it seems like most people are pretty tall. And the shoe sizes varies a lot for this height. So yeah.
Oh, also, one thing I think we need to keep in mind is I think that there's different units that everybody inserted for
Oh,
exercise. So it's pretty cool,
all right.
actually.
Yeah, that's cool.
Yeah.
Um, yeah, I didn't think of that. Yeah. All right, awesome. So that is the end of our presentation today. I just want to make like one last announcement. For those of you that are in high school, I'm gonna be um, dropping the interest form in the Discord channel for Big Data, and it's gonna be for Big Data's high school data science bootcamp. So if you guys are interested in data science, I definitely encourage you to fill out that form. And it's a data science bootcamp for like beginners. It's an introductory bootcamp. So if you don't have too much experience or any experience, a great point to start off. We'll be teaching you Python and statistics concepts from the ground up. So it doesn't assume any prior knowledge. The application will be coming out in September. So this is just an interest form and we'll notify you when that's out. And the program will start in October. It's an 8-week long program, and we'll have people from some Bay Area companies coming in as well to speak. So yeah, should be cool. And if that sounds like fun, I definitely encourage you to sign up for that. But yeah, that's all I have. Milan, is there anything you wanted to add?
No, I just wanted to say it's really cool to see everybody kind of work on workshops like this and work on hackathons. I think a lot of you guys are freshmen. You guys are a really great place, and it's really good to see everybody taking initiative to learn. So continue learning, continue using all the resources Daniel shared, and just grow your skills. And yeah, that's all I have for you guys.
All right, thanks for coming, guys. Hope you learned something cool. All right, see you guys later.
Everyone has a good day.
I'll be hanging out here for a little bit too, so you can drop questions as you leave.